Atomic structure. All matter is made of atoms, and an atom is the smallest unit of an element which maintains the properties of that element. It comes from the Greek word atomos, which means indivisible. Atoms are small, and by small we mean 2 times 10 to the minus 10 meters. That's 0.2 nanometers across. Everything in the universe is made of atoms, and atoms themselves are made up of smaller pieces called subatomic particles, and there are 3 types of subatomic particle. In these pictures of atoms, you can see the subatomic particles. In the centre, in the nucleus, there are 2 types of particle, the neutron and the proton, and whizzing around them in orbitals or shells are the electrons. So inside the nucleus, we have protons. We've called them massive particles here. By that we mean they have mass, not that they are big. And the mass, we'll call it 1 AMU. That stands for atomic mass unit. Protons have a positive charge, +1. And it's the number of protons that gives us the name or the identity of the atom. So when the atom has 1 proton, it's hydrogen. In those pictures before, when it had 3 protons, it was lithium. When it had 8 protons, it was oxygen. There's nothing else that can tell you the type of element or atom. It's always the protons. Also in the nucleus are the neutrons. They also have mass. It's also 1 atomic mass unit, the same as a proton. But they don't have a charge. They are neutral, hence their name neutrons. Their main function is to stop those protons that are all positively charged from just flying apart and repelling each other, because we know that like charges repel. So somehow those neutrons glue the nucleus together. Around the nucleus, we've got this fuzzy cloud. Remember, it's very far away from the nucleus, not quite as close as that diagram showed. And the electrons in that fuzzy cloud, they're really small and they're really light. They only weigh about 1/2000th of a proton. So essentially, we say they weigh nothing. The electrons are negatively charged, -1. And because they balance out the charge on a proton, in an atom, the number of electrons equals the number of protons. The electrons move at random within the cloud, which is not quite true. They do have specific places that they move. These are called orbitals or shells. And it's actually only the outer orbital or the outer shell that comes into contact with other atoms during chemical reactions. So electrons travel around in the cloud in particular places, and they can be arranged within shells that have rules about how many electrons can live in those shells. So the first energy shell, which is closest to the nucleus, can only hold 2 electrons. Second energy shell, the second shell away from the nucleus, can hold up to 8 electrons. And the third energy shell, also we consider it to hold 8 electrons, because that takes us up to calcium. For numbers above calcium, for all the atomic numbers above calcium, it can hold up to 18 electrons. We give these outer shell of electrons a special name called the valence electrons. That's going to come in useful when we start looking at forming compounds. Let's look at how the periodic table can also help us to understand atomic structure. Here's the periodic table. All elements can be found on the periodic table. And the periodic table is arranged in a specific pattern, and the pattern is based on the number of protons. So you'll see that there's number 1 for hydrogen on the top left, and there's number 2 for helium on the top right. And then the numbers go up in order: 3 for lithium, 4 for beryllium, 5 for boron, 6 for carbon, and so on, across the rows, which are the periods of the periodic table. There are lots of patterns and lots of information in the periodic table which will help us to understand the chemical reactions we're going to be studying. Looking at each square on the periodic table, we can get heaps of information. The element name, the atomic number, which is the number of protons, which of course is equal to the number of electrons, the atomic symbol, the atomic mass or the mass number, and that's made up of the number of protons added to the number of neutrons, because of course those are the two subatomic particles that have mass in an element or in an atom. So what if we did need to know just the number of neutrons? That information on its own was not present on the periodic table, but we can work it out quite easily. The atomic mass or the mass number is when you have the number of protons and neutrons added together. So just a little bit of simple maths. We can take the atomic mass minus the atomic number, and we're left with the number of neutrons. So in molybdenum, we have 95.94, take away 42, and we're left with 53.94. You can't really get 0.94 of a subatomic particle, so if you round it up to the nearest whole number, there are 54 neutrons in a molybdenum atom. So if we go back to the beginning of the periodic table, the simplest element on there, the simplest atom structure, is hydrogen. We know from the periodic table that it's atomic number 1. It has a symbol H, capital H, and because the atomic number is 1, that's also the number of protons. We can work out the neutrons using our simple maths. We take the atomic mass or the mass number, which for hydrogen is also 1. We take away the atomic number, which is 1, and we're left with no neutrons. Hydrogen is the only element which has no neutrons. To work out the number of electrons, it just equals the number of protons because they have to cancel each other out. All the pluses and the minuses have to balance. And we know from our understanding of where electrons go in their energy shells, there must be 1 electron in the first shell orbiting the nucleus.